Alright, take three. So the core idea of our project was to highlight the differences in noise levels between different areas on campus. And so to achieve this, we created what we're calling a jukebox, which has the capability of both recording ambient noise levels in its vicinity and then switching to a different mode and playing back some sort of noise with the volume level being based on the ambient noise level it recorded. So to talk a bit more about these two different modes, we have record mode, in which we use a sensor to record the current volume level and store that data into memory. And then we have playback mode, where we read the stored volume level and then play back noise with the volume being controlled based on the recorded value. And we have two different tracks representing two different locations we chose for the Skiles and Colk, and those two different tracks can each be recorded and played back independently of each other. So for our audio recording, we use the SmartFun electronic sensor, and while this sensor produces multiple outputs, the only one we really cared about was the volume level reading. And so we would read in that volume level from the sensor, and then we would calculate a rolling average of that volume over time, and we would use that as the environmental noise level in that area. And we actually manually removed a built-in resistor into the sensor to increase the sensitivity of it further and make it more suitable for detecting atmospheric noise. So once we record the rolling average from our SmartFun electronic sensor, we then use the Arduino's EEPROM, which is a built-in form of non-volatile memory, to store that data persistently. So even when the device is powered off, we'll still have our values stored that we recorded before. And then we can read those values back from memory and use them to control a piezo buzzer using the tone library, which allows us to control the volume, and we set the volume level based on the recorded ambient noise level.